Okay, would like to welcome you to the next event lecture in our series, Higher Meanings, Exploring Connections Between Religion and Mathematics. It's a part of a national program called Scientists in Synagogues. I'm Rabbi Ben Zeidman, here from Temple Mount Sinai. I'm joined this evening by my partner in this effort, Dr. Larry Lesser. And we are so happy to be a part of this grassroots initiative run by Sinai and Synapses, which is also supported by CLAL, the National Jewish Center for Learning and Leadership, in consultation with the Dialogue on Science, Ethics, and Religion program of the American Association for the Advancement of Science. And it is also funded by the John Templeton Foundation, as well as other donors. So we are grateful to our local support, both Temple Mount Sinai, as well as the University of Texas at El Paso, particularly the UTEP Religious Studies program, the UTEP Computer Science Department, and UTEP's Mathematical Sciences Department as well. We're grateful to all of them there at University of Texas, El Paso as well. And just a few logistical details for our conversation this evening. We are recording. When you'd like to share some of the details about this evening's conversation with friends and relatives and strangers perhaps, please share with them that it was recorded and it will be available on our YouTube channel pretty quickly after we are done with this evening's conversation. We have muted everybody. If for some reason you notice that you are unmuted, it shouldn't be possible, but you know, stranger things have happened on Zoom. Please then try to mute yourself. We will help to mute you until the Q&A at the end. We will probably take Q&A questions at the end by chat, meaning that if you have a question at any point along the way, please feel free to enter a question into the chat window. And our moderator, Dr. Larry Lesser, professor of mathematics at University of Texas, El Paso, will be collecting those questions and can ask them at the appropriate time as well. And I'm glad to have that reminder there. I am turning on the closed captions for those who may find that to be helpful. I'm sorry, give me one moment. And let's see, hopefully that's going to work. There is a way to turn that off, which is to go down, click on live transcript and select hide subtitle if you find that that is frustrating to you. And then lastly, at the end of the conversation this evening, we will be providing a link to a Google Form survey. We hope that all of you will take the time to fill that out to help us to think about and reflect on what it is that we're presenting, why it matters, what brings you to this conversation this evening, what you may be taking away with you. And it's something that we're going to be looking very carefully at. And giving to the results of which are anonymous, we'll be giving to some of our partners as they think about the ongoing need for conversations about the intersection between religion and mathematics, and as well as religion and science. I'm going to turn my slides off there because I am not the main presenter, and just introduce our presenters, Vladek and Olga Kreinovich, who are very special to all of us here in El Paso. As you can see, I'll show you the full details here that we have 3 conversations left in this series. This evening's conversation, and then our next conversation with Dr. Snezana Lawrence will be Sunday, October 17th at 1 p.m. Mountain Time. And then a conversation December 16th at 6:30 p.m. Mountain Time with Dr. David Novick. And we're very excited for those as well. You can kind of get a sense of the full course of the series here. Dr. Olga Kosheleva, Dr. Vladek Kreinovich are based here in El Paso, members of Temple Mount Sinai. They are originally from Russia, emigrated in 1989. They came to El Paso and joined Temple Mount Sinai in 1990. At present, they both teach at the University of Texas at El Paso. Olga teaches future teachers and co-chairs the teacher education department, while Vladek teaches computer science. That is the extent of the bio that they permitted me to share with you. Suffice it to say that the details about their professional careers are vast, and the number of awards that they both have individually and the number of publications that they've done together as well it's a very long list. And so we're grateful to you, Olga, to you, Vladek, Dr. Kosheleva, Dr. Kreinovich. Thank you so much for your time this evening, and we will turn it over to you.
Thank you very much. Thank you for the great introduction. So let me start sharing. Okay, so this is the title of the talk. Let me do what the title is Mathematics, Computing, Ethics, and Religion, from Naive Contradictions to Deep Agreement. So we will say outrageous things in the beginning. Don't get mad, don't kind of call the police on us, because we will kind of calm down and get to the point later. But we will start with contradictions, yes. So first is naive view. And in order to explain where this naive view comes from, let me just tell very briefly the history. Several years ago, when we were in Israel, Israel in general is not exactly Germany. It's not a very place where everything goes by railroad schedule. But there is one place which does, which is the Western Wall Tunnel. If you miss 1 minute, they will not let you in. You'll have to wait for the next turn. And that's exactly what happened to our group. So we were late. And so what our tour guide did is he brought us to the museum. And at that museum, we were shown a model of the temple. And our tour guide was kind of very nervous because this museum, as it turned out, is run by, well, unusual people, so to say, who believe that temple should be restored exactly as it is. And as our tour guide explained to us, one reason that they're not very much insisting on it is that while the Bible seems to be describing exactly in very precise mathematical details the lengths in cubits of this, the width of cubit and that, these details just don't match. There is no way to fit this temple on this particular place with all the measurements that are there. And he explained it very simply. The Bible was written by poets, by prophets, not by engineers. Numbers don't match. This is not a unique case of the Bible. There are many such inconsistencies, even in terms of how many years people lived. And actually Spinoza, the famous philosopher who was kind of first a big specialist in the Bible, in Talmud and everything, he noticed a lot of this inconsistency and he publicized them. And that was one of the reasons why he was excommunicated, because how can there be inconsistencies in the word of God? So there is an example, classical example. If you look at the Bible, at some point, the altar in which the sacrifices were made, and the circumference of this altar is exactly 3 times its diameter. Not pi 3.114, no, exactly 3. And it was like people who believe in that literally. In the 19th century, in the state of Indiana, legislature seriously considered declaring pi equal to be 3 because this is what God says in the Bible. So, on the other hand, according to our tour guide, which we confirmed later, if you look at the books by Josephus Flavius, and here is the photo of the statue of Josephus Flavius. It's the other way around. When he talks politics, he talks through his teeth. It doesn't match what others are saying. But when he talks about like they marched for 10 miles, actually mile was the original Roman unit of length. It meant 1,000 steps, and made a camp. You can dig there and find the remainder of these camp. And that's exactly what Israeli archaeologists have been doing. So it looks like math and Bibles do not match at all. So how can a mathematician take the Bible seriously? If we take the Bible numbers seriously, then not only they don't match between themselves, they don't match any science. For example, the world was created in 6 days, when 6,000 years ago, dinosaurs, old rocks, nothing exists, only 6,000, and that's it. So gays should be put to death. When you conquer the enemy, you should kill their women and children. And people, unfortunately, in the history took these instructions very literally. That's Inquisition was doing that, religious terrorists was doing that. And if you think Islam is different, a lot of stories of Quran are basically the same stories that we have in the Bible. So how can a person who is ethical believe in all this? Well, let's have another example. Many people believe that atomic bomb is evil. Well, it was used for killing people, as all the weapons are. So who created atomic bomb? Physicists. So what does it mean that physics is evil? How did they create it? Well, they use some mathematics. They use some computation. So conclusion, mathematics is evil, computing is evil. Why there are financial crises in the world? Well, one reason is people relied on simplified mathematical models. There is a whole book, you see, the skull and bones, everything, weapons of mass destructions, describing how belief in mathematical model leads to economic crisis. So what shall we do? Destroy all the computers, stop teaching mathematics. Well, some kids will love that part. Close all the churches and synagogues. Well, it kind of sounds a little bit too much. So after we have these outrageous conclusions, let's start digging deeper. Mathematics, computing, ethics, and religion, let us dig deeper. So, is it true that the Bible is not so good about numbers? Absolutely. How is it related to mathematics? Well, there is a common misconception that mathematics is a science of numbers. It's not. Mathematicians are not very good in computing. People who are good in computing, well, in the old days, they could earn the living by going on stage and multiplying 4-digit numbers real fast without using piece of paper. Not mathematicians. I remember at one of the seminars when one of the speakers got confused in simple computations, our professor kind of noticed that in general, that's a sign of a true mathematician, that this person is thinking very abstractly. He is not really able to multiply or add correctly. What mathematics is about, it's about proofs. When you compute, it's not mathematics. Mathematics is when you prove. And here is a classical example. There is a known thing called Pythagoras Theorem, that if you have a right triangle, then the square of the hypotenuse is the sum of the squares of the sides. This was known by Babylonians, it was known by Egyptians. And they knew it, Babylonians knew it, and Egyptians knew it from practice. For example, if you have 3 and 4, first 2 legs of the right triangle, then 3 square plus 4 square is 5 square. And this is exactly how they got a right angle in their constructions. They took 3 rods of lengths 3, 4, and 5, put them together, and that became a precise right angle. And again, this is, I cannot claim that I understand how is it related to this, but people who read Babylonian scripts, they say that this is exactly what is described here. But the difference is Pythagoras, why is it called Pythagoras theorem? Because he was proving it. Why do we need to prove? Well, what the Egyptians and Babylonians also knew is that pi is approximately equal to 3 1/7. But it turned out to be only approximately true. But why is it important? In the first case, it's exact. In the second, it's approximate. Big deal. In practice, we don't have that. Well, if you are building a pyramid, you may use this approximate value of pi. If the pyramid is a little bit like 1 meter to the left, 1 meter to the right, no big deal. But if you are doing something more precise, for example, you're predicting solar eclipses centuries ahead and use approximate formulas, errors accumulate. That was, by the way, one of the reasons why Einstein got interested in changing Newton's physics, because there was a discrepancy between the orbit of Mercury. And prediction was important because people were scared of eclipses. Supposedly the sun goes out. It's scary. That's a legend. Well, again, it's a legend about the Aztecs, how they started sacrificing people. That supposedly there was an eclipse, and so the sun went out. And so they were scared. The sun is the source of life, and suddenly it's out. So what did they know? Well, you need to sacrifice something. So they sacrificed a chicken, and the sun continued staying. Then they sacrificed a cow, and the sun continued staying. And then the bravest member of the tribe says, the god needs supreme sacrifice. And so he killed himself, and the sun came out. And that explains why they had this tradition that every year they would have like a football competition, a championship, and then the champion, the hero, would be officially sacrificed to the gods. The history of this Pythagoras theorem is a good example of how science works. First, you have some informal ideas. They are very raw. Then they get confirmed experimentally. Like pi is equal to approximately 3. Okay, well, 3 1/7 is better, and so on. And then finally, at some point, somebody derives them from first principles, and then it becomes either laws of nature if it is physics, or theorems if it is mathematics. And so in general, that's how many scientific discoveries were made. And that's kind of almost kind of divine inspiration. Like there's a famous Indian mathematician, Ramanujan, who really believed that he gets inspiration from the gods. And it's not just in mathematics. Many ideas of modern physics actually are based on the ideas that were proposed many, many centuries ago. Or like very simple example, atoms. Atoms were experimentally discovered only in late 19th century and definitely in the 20th century, but they were known in ancient Greece. The relativity principle, for which Einstein is famous, was actually formulated first, not by Einstein, but many, many centuries before that by Galileo. Galileo had a very simple observation that if you are in the ship's cabin, you don't look outside, the water is very calm, you don't feel the motion, you don't know whether you're moving or not. Steam engine was invented in the 19th century, but in reality, it was invented already in the ancient Egypt, in Alexandria. Here is the picture of this ancient steam engine. Well, why don't we know that? Well, because it was not used to do anything useful. There were plenty of cheap labor at that time. What it was used for is to open the doors of the temple. And that was an interesting period because there were many gods. And one problem when you have many gods is there is a big competition between different temples. So you bring some money, you bring some sacrifices. Do you sacrifice to Zeus? Do you sacrifice to Athena? Do you sacrifice to, I don't know, Poseidon, whatever it is. And so if in one temple, you go in there and then suddenly, magically, the doors open and nobody is opening them by themselves. And a lot of kind of cloud of steam comes out. What's your natural reaction? Your natural reaction is take out your wallet and give some money to that particular temple. That was the only reason for using this steam engine. How is it related to science? Well, again, many ideas can be found in myths and in holy books, not just in the Bible. For example, according to modern physics, our universe had a beginning, which scientists call a Big Bang. And these ideas can be traced to the Bible, where, of course, the world was created. And there are many other holy books which have similar creation stories. Moreover, in the beginning, what did God say? God said, let there be light. And indeed, that's exactly what physicists noticed, that at the first, we had the period where the universe was filled with light. And many discoveries of quantum physics similarly can be traced to the ancient books by Hindu religion. So some writers conclude, and there are many of them, some journalists, well, there is nothing new in modern science. It's already was known to the ancients. And actually, even some Jewish kind of Orthodox people believe that. But this is a naive oversimplification. It's not exactly the same. There is a big difference. On the one hand, Galilei said, yes, we're in the ship's cabin, in good weather, we don't feel any motion. But what relativity theory does is not just staying at this point, it has some formulas that enables us to predict exactly how to compute locations based, for example, on GPS signals. As you probably know, with GPS signals, if you don't take into account relativistic effects with movements of satellites and everything, you miss by kilometers. Same thing, the Bible says the world was full of light, and modern physics say exactly the same thing. Fine, but the difference is, it's modern cosmology, modern physics doesn't just predict what is full of light. It predicts exactly what we will observe with radio telescope, so-called 3K radiation, which of course you cannot predict based only on the biblical stories. Some scientists make another mistake. They think, well, science is everything. Everything else, all these informal things is unnecessary. Dismiss all these informal arguments altogether. This makes a nice history of science. Nobody knew anything. Then suddenly comes this genius Einstein, genius Newton, whatever it is, and everything becomes known. Well, it's a simplification, and even the great scientists realize that this is a simplification. For example, Einstein, who pioneered the idea that the geometry of the world, of the space-time, is not Euclidean, he himself said several times that he got more from Dostoevsky, the Russian writer, who had a lot of informal ideas about non-Euclidean things. This is Dostoevsky. He looks a little crazy, and he was a little crazy, but he was a great writer. Then from Carl Friedrich Gauss, who looks very sane, who was a great mathematician, and who actually discovered, one of the discoverers of non-Euclidean, one of the promoters of non-Euclidean geometry. So biblical and other myths inspired many scientific theories. So, okay, so maybe we should relocate the Bible and other holy books to history. Great, in the past, when there was no modern physics, no modern mathematics, people had some primitive ideas. That's great, wonderful, let's applaud these guys. But nowadays, why do we need them? Well, it turns out that we still need this original myth. There are still ideas that can be and need to be formalized. And here is an example. An example is that what do you do in the case of bankruptcy? Bankruptcy is not a modern problem. Of course, it existed in the ancient times. And in the ancient times, there was always a question. What is bankruptcy? You owe a lot of money and you don't have enough to pay everybody. How do you divide? Different cultures have different ideas, and the Talmud, of course, touches this because Talmud touches everything. The problem is, unlike modern textbooks, the Talmud doesn't give formulas. It only gives examples. And in other cases, it's usually in simpler cases, it's very clear. For example, if you have to contribute, I don't know, 1/10, and they give some examples, and it's clear that what they mean is to give 1/10 or 1/60 or whatever it is. But unfortunately, in this particular example of a bankruptcy, this idea was completely lost. And here I'm reproducing in a simplified way what exactly the Talmud says. There are two examples, actually 5. In one of them, it shows how much, so suppose we have 100 whatever units. Of course, it was not dollars at the time, shekels probably. So if the first person was owed 100 shekels, second 200, third 300. If all you have is, so totally that's what? 100 plus 200 plus 300, 600. Totally, it's 600. If you only have 100, how do you divide them? According to the Talmud, you divide them equally. 33 and 1/3 to each person. If you have 200, then the first person who was owed 100 gets 50, the other two get 75. If it's 300, everybody gets half of what they owe. And then there is another case, and it's kind of weird. This is in two places in Babylonian Talmud, and it was a big mystery until literally like 10 or 20 years ago, when there was a Nobel Prize winner, Robert Aumann, and he's this unusual picture because normally he wears a kippah. He's very orthodox, but this is one of the few photos where you can see his whole head without a kippah. So he gave a formula that explains all Talmudic examples. And moreover, not only he gave a formula, he showed that one of the dozen game theoretic concepts leads exactly to this Talmudic formula. And Olga and I, why we know that? Because with one of our colleagues from California, we kind of also added a little bit. We showed that the Talmudic solution is in some sense better than the other 11. So this makes sense. So the ancient rabbis had intuition, and modern game theory, which is used by Aumann, enables to transform this intuition in precise terms. And there are many such examples of religion-inspired, holy book-inspired research results that make us believe that hopefully there are many other examples still to be discovered in the teachings of the holy books. In other words, from this viewpoint, religion and science supplement each other. Religion provides some intuitive ideas, and science helps how to transform them into something very precise. But of course, people don't go to the temple to describe how the world is built. When people go to the temple, usually they are more interested in ethical aspects. So what about ethics? How is ethics related to mathematics? Again, at first glance, it doesn't. And if you look at the title of that book, it's awful. Mathematics is very unethical. But our Russian teacher, and here Olga will say a few words, taught us that teaching mathematics, here is the picture of Alexandrov. We selected a picture where he's not looking very official. This is how we know him.
Yeah. He was a great person, and he was always teaching by his example, and he liked contradictions. He liked to surprise people. And I think he never prepared ahead of time for lecture.
Well,
he would come.
We don't follow that example.
and start talking, and then talk very interestingly.
Yeah. But his idea was the main important things, how to make people ethical, is to teach them mathematics. It sounds weird, but he gave an argument, because what is it, mathematics? Mathematics is not about adding numbers. It's not about solving a quadratic equation. It's about proving. A mathematician knows that if you have a statement, you need to prove it. You cannot just say, famous researcher says, and therefore it's true. Communist Party says, therefore it's true. The rabbi says, sorry, rabbi, it's not, we still have to believe in it. New York Times wrote, of course, it's absolute truth. How can New York Times say something wrong? And in mathematics, we also know it's not just our prejudice. We know that famous mathematicians sometimes are wrong. That was a classical case. David Hilbert, the most famous mathematician, he was well known, so well known, and so kind of praised as the top mathematician of the end of the 19th century, that in 1900, he was tasked with formulating problems that the mathematicians of 19th century should give as challenges to mathematics of 20th century. And not only he formulated open questions, he tried to guess what will be the answer. And of course, being a great mathematician, in about 20 of these 23 problems, he guessed correctly. But in some of them, he goofed completely. And I'll just mention it. But one of his guess was that you cannot describe every function as a composition of functions of two variables. It turned out to be wrong. And in some sense, all the modern neural networks, deep learning, and all this success is based exactly on this fact that he was wrong in this prediction. But let's go back to ethics. So what mathematics teaches us is that you need to think on your own. You need to be convinced on your own. The proof is only a proof that you are convinced. So, but you may say, wait a second, religion is the opposite, right? We just follow without thinking. Well, not really the religion that we believe in, because of course, there is what is called fundamentalists. Fundamentalists don't think. They read the text and they follow it. Actually, in Russia, we studied kind of Lenin's papers, and the word Talmudist was a curse, was a bad word. Why? Because there are many guys in his time who studied Talmud, not because they wanted to learn better, they just memorized everything. And instead of arguing, they would say, well, the Talmud says this, so this is what we will follow. I don't know why. God knows why. I don't know what will happen, but since the God said that, it's right there in the book. And of course, other Talmudists cited other parts from Talmud. And that's exactly what Lenin was comparing people to. So this fundamentalists, they say, I don't care about geology. I don't know about dinosaurs. It's all a fake. Here is the book. The Holy Book says the world was created in 6 days. That's it. And if you believe otherwise, well, they don't have the power to burn you at stake nowadays, but still but this is not what serious religions teach. According to the Bible, why was Abraham selected by God? Not because he was obedient. Abraham was selected, why? According to the Bible, because he argued with God several times and succeeded. Why are we called Israel? Israel literally means the one fought with God, because we fought with God, not because we obeyed God. This is the famous story. Well, again, you can interpret it differently with an angel, with God, whatever it is, but clearly you're fighting with some will. You are showing that you are not exactly obedient. And Talmud, it's not a list of prescriptions. It is basically a discussion club. For every point, you have different rabbis who present absolutely different opinions, and not just present opinions, they present arguments. And they justify their views. And the true goal of people who study Talmud seriously is not to memorize, although memorizing is nothing wrong with that, but what they do is they understand the argument and they use them to make decisions. That's the whole point. This is a typical page from the Talmud. And Rabbi probably will understand better what is going on. But usually it's what? There is Mishnah, which is in the middle, which is kind of comment. Then there is a comment on the comment and so on. And then there is some comments there. And overall, you can basically have whatever you want. From this viewpoint, both mathematics and religion teach basically the same thing. Although you may not expect it from mathematics, you may not expect it from religion, but that's exactly what they teach. Defy authority. Here is the illustration about defying authority. It doesn't mean anarchy. It doesn't mean ignoring or burning the books. It doesn't mean not listening to the elders, as was popular saying in the 1960s until these. So don't trust anybody over 30. That, of course, changed when those people who proclaimed that became over 30 themselves. No, we need to listen attentively. We need to read the books because, yes, a lot of ideas that are there in the books, they are valuable ideas, and many ideas that we think are new can be found there. Yes, as we showed with example of physics and mathematics and everything there. But after that, after you read those ideas. After you argue, then you have to make your own mind. And again, just like the rabbis, they couldn't convince, not that they managed convincing each other. No, they stayed of different opinions, and it's healthy and it's reasonable. As long as you're not imposing these different opinions, as long as you have reasonable arguments about your opinions, you are able to have your own arguments. Like, for example, it's naive to think that some of them were evil, some of them were good. Actually, according to the stories, all the rabbis were kind of, as the rabbi probably described better, the celestial voice came when they were arguing and then said they're both words of the living God. That's exactly what we have to keep in mind. So what is the final conclusion? In our opinion, what does the history of the 20th century teach us? It teaches that evil happens when people follow authority without thinking, whether it's Mein Kampf by Hitler, whether it is the Das Kapital by Karl Marx. Karl Marx had lots of good economic ideas. His economists consider him very seriously. But if you just follow literally everything that is written there without thinking too much, that inevitably leads to evil. We all need to be independent thinkers, and that's the only way, the only key to an ethical society. And in this, mathematics and religions are in very good agreement. And moreover, deep study of mathematics and deep study of religion leads to exactly the same result, that we do become more independent thinkers. We do understand that you need to follow examples. That's why the rabbi is not a person who is kind of tells us what to do. The rabbi is a person who is helping us come up with our own decisions based on his deeper than ours knowledge of the holy books, knowledge of religion, knowledge of this tradition. So from this viewpoint, our conclusion is we need to follow this great advice to be independent thinkers. And we are very much thankful to the rabbi, to Rabbi Zeidman, and to Professor Larry Lesser for their invitation, their inspiration, and their valuable advice. Again, it's not like we came up with this idea and the rabbis and Larry are listening it from the first time. We showed them our drafts. They gave us a lot of good advices, and I think hopefully that helped make it more understandable. And those who really, really want to see technical details, we have several papers. We have a paper, mathematical paper, so don't kind of, if you're afraid of mathematics, don't go there, but if you are interested, please do. There is a paper on our motivation for this bankruptcy solution. There is a corresponding slides. And there are some other papers that we wrote on these topics, like one of the examples is, Balaam, the prophet, who is well known from the Bible because it's part of the story about the talking donkey. He had this famous blessing, Ma Tovu, how great are your tents are Israel. So in what sense are they great? He came from some rich kingdom. So these tents clearly could not be the richest. They were probably not the best made because living in the desert doesn't make you a great kind of writer. So in what sense were they great? And so what the rabbis concluded is they were great because they provided privacy. If you stand in the opening of one tent, you see as little as possible about what's happening in the other tents. And it turned out this leads to an interesting geometric configuration, which kind of shows what is similar to, kind of helps understand where the Solomon's seal come from. Then there are some papers related to other religions. For example, Mayan mathematics, they had these ideas of zero and infinity, which also looks like simple, naive interpretations, raw ideas that eventually led to some mathematics. Then there is Maimonides, so-called double negation theology, where Maimonides claimed that you cannot say anything about God positively. You can only make negative statements. You cannot say God is, you can say God is not finite, God is not understandable, and so on. And there is another, Tertullian's, the Christian guy. And there was also, we had a paper by Gödel, again, one of the great mathematicians, who had a proof that God exists, which kind of not exactly a mathematical proof, but still some arguments. So thank you very much. And we will be glad to answer our questions.
Thank you so much, Drs. Kosheleva and Kreinovich, for giving us such a rich context for our thinking about how religion and ethics connect to mathematics and computing. I mean, you showed us how what superficially appears to be a contradiction can be resolved with a deeper view. And I'll just add on a personal note, I'm starting my 18th year, my Chai year at UTEP. And so it's been my privilege to be a UTEP colleague with you for this long. And we've shared experiences like grant writing and article writing and conference talks and mentoring students and serving on their thesis committees. And I've always been impressed at how your scholarship and your insights have been able to cross realms. And tonight, of course, was no exception. And so we will now move into the evening's Q&A portion. And I happen to have a couple of questions I have myself while we wait for others to start typing theirs in as well. I see you have a statement, Tina. I don't know if you want to make a question out of that, for example. Also at this time, Rabbi Zeidman will paste into the chat window the link for the 2-minute anonymous Google Forms survey that we would like each attendee to complete to give us feedback about this session of our speaker series. So our speakers, so you gave examples of the pitfalls of overhyping science and also of overhyping religion. Do you have any thoughts on how one might best forge and maintain sort of this middle path, middle ground that avoids both of those pitfalls?
Well, again, as kind of a scientist myself, I believe in experiment. So if you follow some theory for too long, for example, there's what happens in social scientists. There is a lot of very good descriptions, for example, of what is social justice, how to best divide things and everything. They seem reasonable. And then what happens when you try to apply them, they ignore some factors. And you look at the results and they don't sound right. That also always happens in economics. People try to raise GDP and everything, and they make calculations. That's actually what the communists started with. They didn't say, well, we come to power to put people to jail, to concentration camps. They said, we come to power to make people happier. They replaced all the private planning with the state planning. They, at some point, at first, they involved great economists like Vasily Leontiev, who later became a Nobel Prize winner, and others were involved. The problem is, if you use approximate model, you trust the model too much, the results can be sometimes disastrous. GDP grows, and same thing happens in the US economy as well. GDP grows, but for example, unemployment rises and something. And so the idea is you don't take all these scientific results as absolute truth. They're not mathematical axioms. They are approximate model. If you trust them too much, you get as bad results if you trust too much holy books. So I think we have to use common sense. And we have to collaborate with each other in this sense. For example, economist is kind of looks, some macroeconomists, they look the big picture, but they need to get together with people who are doing social work and everything and see how this translates on the local level. That's kind of my idea.
Thank you. And I really loved your description of how religion can be a source of intuition, and then science can be brought in to achieve precision. What I was curious about, though, is what role do you think intuition plays for scientists who view themselves as secular?
Well, again, religion is a relative kind of notion. To very orthodox people, we who go to Temple Mount Sinai, we are, as they say, goyim on the hill. So we're not exactly religious. So we kind of, what is religion and what is not? Like many people in California, they say we're not religious, but they still use all this kind of sacred texts and everything, and kind of, so I think intuition can form in many ways. To me, science, religion is just one of the possible sources of intuition. Art is another source, like I cited Einstein, who cited Dostoevsky. And of course, it was raw ideas, but these ideas were not formulated in a research paper or in a sermon. They were formulated in a novel. So art, music, everything, and meditation is actually kind of a non-religion idea. And that's what kind of, again, it's experimentally shown that listening to music or doing meditation and everything helps researchers become creative.
Yeah, I can add a little bit. I read dissertation by Vygotsky, and it's called Psychology of Art. And there are a lot of interesting examples about art serving as some kind of intuition.
You remember a particular example you'd like to share?
No. But it was very interesting dissertation, and a lot of examples were kind of, it was very interesting experiment because my doctoral student, she was reading it in English and I was reading it in Russian. And I helped her to understand it better. So, yeah.
Well, this is kind of one of the cases. Vygotsky was a scientist, but what he wrote reads more like a novel, in the sense that it's not like a precise mathematical formulas, it's intuition. And again, I just read very few pages, but when I read it in Russian, I don't quite understand. When I read in English, I don't quite understand. When I read both texts, I start getting an idea, because I think those who translated, they had some understanding. And it's true for many things about social science.
Nice. By the way, I just want to give a quick shout out to our previous speaker, our June speaker, Victor Katz, is in the audience. Hello, Victor. So here's another question for y'all, Olga and Vladek. You made the very interesting point that math and religion both call for questioning authority, but after reading the books and after listening to the elders. And I guess my question is, since it can take, decades to take in all the wisdom the elders and the books have to say, how do we make space to appropriately defy authority along the way?
Well, that's a tough question. You need to make decisions, as they say in decision theory, under uncertainty. Yeah, absolutely. And that's a big problem. For example, economists cannot spend, the classical problem is not related to human beings, is modern computers can predict weather the next day, usually very well, although in El Paso we've seen counterexamples. Same program can predict where a tornado can move in the next 15 minutes, but predicting weather takes several hours on the high-performance computer. And so there is no way that we can spend this time waiting, because after this call, waiting to compute where the tornado will move, because by that time it will already have moved. So you have to make a decision, and that's kind of a judgment call. How much you listen to authority, how much you do things. So honestly, that's what kind of people do in military situations. That's what people do in emergency situations. That's what medical doctors do when there is somebody's in kind of in not very good health and you need to do something right away. And sometimes they make mistakes, but I think there is a good, healthy compromise between listening to authority and listening to your own intuition.
Rabbi Zeidman, maybe this is a nice moment to allow you to weigh in, because our speakers have basically said we can't just do something because a rabbi told them to. So hopefully this doesn't disillusion anyone on the call. But would you like to talk about the nature of authority and questioning authority from a rabbi's point of view?
Well, that's what rabbis do, if we, really think about it. And I think, it's one of the core concepts within Judaism. And Bernard Henri Lévy writes about this beautifully in the Genius of Judaism. You can skip the second middle section of his book, which is about French, modern French philosophy, especially if you're not a French philosophy buff. But the last part of his book really talks about how the genius of Judaism is about the expectation that we have as Jews that every single individual Jew has to have a critical enough mind to ask questions and to challenge the things that they are being told to assume. Whether that, and that is, as Doctors Vlada Kreinovich and Olga Kosheleva shared, is the core or the crux of what Talmud really is. It is not just assuming that the Torah is what, as it's written in the scroll, is what we should do, right? It's about, okay, that's what's written, but what does it mean? And it's not just even stopping there, but okay, now the first rabbis have said this, but what does it mean, right? So there's always that next step, that question of, okay, so we're being told this thing, but what does it mean? And it's not just the rabbis who ask that question, it's every person who's supposed to ask those questions. And that's what it means to be engaging in what makes Judaism beautiful, or as Lévy talks about, that's what is the genius of Judaism and ensures its survival, is that it's never just, here's what the authority says and that's it. That is core, foundational to what Judaism is really about. So, I think that that's one of the reasons why, we have conversations about mathematics and the connection of mathematics and Judaism, or science and Judaism in the first place, is because so much of what it means to be a Jew is what it means to be, a rational, scientific thinker in the world, which is to say, here's what we have, but what does it mean? Like, what do we do with it? What is that? What's next? What do we learn from it? Never just to say, okay, we're going to accept what we think is true on face value. We're going to accept it on faith, so to speak.
Thank you, Rabbi Zeidman. And to bring the math back into it a little bit, so our speakers mentioned non-Euclidean geometry at one point. And, for centuries, people just assumed Euclidean geometry was the one true geometry, right? And it took till 1800 something for non-Euclidean geometry to be established as equally valid. So I'm curious if you know, and if you don't, we could bring in our math historian, Victor Katz, perhaps. Was it a failure of people to question assumptions, or why did it take so long for them to realize that Euclidean was not the only true geometries?
Well, I don't think we know the exact answer, but I can just tell the story from the Russian viewpoint. Well, first of all, of course, a lot of non-Euclidean geometry was already made by Omar Khayyam. Omar Khayyam is kind of more known for his Rubaiyat, the beautiful poems, who are beautiful in translation in many languages. The interesting thing is that he lived in a Muslim country. Most of his poems are about drinking wine and everything. So at that time, most Islamic countries were like some of the modern Islamic countries. They were not exactly very orthodox. They were kind of more liberal in this sense. He tried to come up, so his arguments were, he was a mathematician and a poet and everything, and he tried to prove the contradiction that geometry should be Euclidean, that to prove this fifth postulate, that if you have a straight line and a point outside, there should be only one line going through it. And he developed his geometry reasonably well. He proved some results which would happen if geometry was non-Euclidean, but he still didn't formulate it in a way that geometry is non-Euclidean. Actually, even Copernicus, in his main famous book, he he didn't say that the Earth rotates around itself and so on. He said, this is a nice hypothesis that helps us predict things. And Lobachevsky, the Russian guy who was the first owner, he came up with these ideas, but it was a very interesting story because he understood that, and it already happened to Janos Bolyai, to the Hungarian who did that. If he tries to publish it, this will not get published because majority will reject it. This is at those days, it was not easy. You cannot just post something on the web. You have to be accepted to a journal. There were very few journals and they were run by majority. If your opinion contradicts majority, you cannot get published. So what Lobachevsky realized is the only way to do it is to have his own publishing house. How did he achieve that? This was, at that time, he lived in Kazan, which was part of the Russian Empire. And under the Tsars, honestly, the situation was not much better than under the communists. So, of course, all intelligentsia was against the Tsar. And so what Lobachevsky did, he started writing articles in the newspapers saying, the great Tsar, he's leading us to the better life. We're all thankful to the Tsar. And of course, these articles were gladly published. So when the previous president of the Kazan University resigned because of some disagreement with the silly government policy, the Tsar said, why don't you appoint this young guy from Kazan? I like him. Lobachevsky is his name. And so he became a president of the university, and he used the power that he was automatically a director of the publishing press, and he published his books. And for the liberal press, it was like a heyday. They say, look what idiots our administration appoints to positions. There is a guy in Kazan who claims that geometry can be non-Euclidean. Ha, 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 ha. And then the good thing, well, not good, but bad things which happened good was Gauss, who was at that time the king of mathematicians, died. And so it's the king of mathematicians. Whatever he did was great. So there was a committee formed that looked at every single piece of paper that he wrote. And they found a manuscript by Gauss in which he himself came up with the conclusion that geometry can be non-Euclidean. But he was afraid to say it because that would be detrimental to his reputation. And after that, Lobachevsky became a hero, non-Euclidean. So I think the main reason is not that people didn't come up with that. The majority was too strong and they prohibited kind of publishing it and arguing about that.
Dr. Katz, do you have anything you'd like to add?
Not much. I mean, I think people just believed, in Euclidean geometry. And although everybody, I mean, lots and lots of people from ancient times on tried to prove, the parallel postulate from the other postulates, and nobody succeeded. And a lot of people actually ended up, they tried to prove it often by contradiction. Suppose this is not true, then what happens? And as Vladek said, I mean, people sometimes came up with results that are part of what we now call non-Euclidean geometry, but they just didn't believe them. It didn't look right. It didn't feel right. So they were just left. I mean, they just couldn't figure out what to do. And it was finally both Bolyai and Lobachevsky that put together a coherent theory that said that, look, we can try a negation of Euclid's fifth postulate, and this is what we come up with. It was only later that people decided that the geometry of the universe might be non-Euclidean. I mean, we don't know, right? They said, well, let's look at this, and we'll try to test it. There's all these things about curvature in space and various things that they tried to test whether in fact the physical geometry of our world is Euclidean or not. for mathematics, it didn't really matter. I mean, it was just that, you know, there are other geometries, and ever since non-Euclidean geometry was introduced and finally accepted in the middle of the 19th century, people have been looking for all sorts of kinds of geometries. As long as they're consistent, and then it's okay. You can see what you can do with it.
Yeah, actually, here is an interesting twist on that one, because actually Gauss himself tried to check whether geometry is Euclidean or not. So what he did is he put one of the conclusions is that he was trying to test whether the sum of the angles of the triangle in real life is 180 degrees. So he went to some mountains, put the 3 points on the top and measured the angles. And he summed up the results of the measurements, and he didn't get 180 degrees, but he was smart enough to try it again. And he tried it again, and he got a different value, also different from 180 degrees. And then he plotted that, and he got his bell-shaped curve, which is the Gaussian distribution. And that's what he published. He never published the reason why he started making this measurement.
So we have another question that just came in. So you mentioned Hilbert, whose axiomatic program was undone by Gödel's incompleteness theorems. William Ruiz says, I don't have a firm grasp of Gödel's proofs, but have been exposed to some informal arguments tangentially relating Gödel's works to spirituality. Have you heard claims of this type, and do you have any insight regarding such claims?
Journalists make a lot of claims like that, because the idea is what Gödel proved is there are some mathematical statements which are true, but which cannot be proved in existing formal theory. And people claimed that sometimes that humans have extra, so to say, sensual abilities. I don't think so. How humans think is kind of, psychologists have a lot of knowledge about that and everything. So, but I think to some extent, these journalists are right in the sense that it shows that you cannot just reduce everything to a formal system. If you have a formal system, you may be able to answer a lot of questions, but still there will be some things that require additional view. So this is like everything else. It's a true statement, but it's sometimes overhyped.
So would the spiritual metaphor be that you may have this highly developed religious worldview, and yet when certain things happen, whether it's the Holocaust or a 2-year-old getting run over by a car, there's just no answers to some questions. Is that kind of what we're saying?
That's an interesting point. No, I didn't. That's a good interpretation. Yes.
Here's a question from Ellen Goodman. Isn't this whole discussion about critical thinking, learning how to learn in order to understand the world, from a nonlinear Gestalt learner and a student of Torah, contact with the world or experiential learning is the way I learn, and it helps me understand the world?
Well, it's more of a statement, not a question, but I would say different people study and learn differently.
I guess the question was at the beginning. At the beginning, she says, isn't this whole discussion come down to learning how to learn in order to understand the world? That's the question.
Well, to some extent, yes, because it's an important thing. But how do you learn how to learn? It's kind of, I can tell you about myself. It's a kind of, do we have a few minutes still? Okay,
yeah, we are at the 1 hour mark. So if people need to leave, please remember to do the survey. If you click on the link, it'll be open. And then as long as you complete the 2-minute survey before you close the window, you can make sure you get it done. But we can keep on going another few minutes. Sure, go ahead.
Yeah, so when I was in like 8th grade in school, there was one young lady who kind of liked me. And so she asked me, who do I think are the smartest kids in the class? And at that time, I was very naive and very simplified. To me, math was the only thing. So I named 5 folks who were good at math. That some people were good in physics or in literature or anything, I didn't care at all. To me, math was the only thing. And I still remember that, but that's unfortunately how people do. And there was the book by Snow, Two Cultures. Some people from art, they do it exactly the other way around. Actually, that got me into trouble because it turned out that all the 5 kids that I mentioned who were good at math were either Jewish or half Jewish. And of course, I didn't realize that, and that young lady didn't realize that, but she told to her grandfather, who realized that very well. So he was, at the next PTO meeting, he said that Vladek is spreading Zionist propaganda and blah, blah, blah. And, and
how is it related to learning to learn?
Well, that's a silly thing, but that's my understanding was that many of our students are like that. They take computer science classes, they love them. They take math classes somewhat grudgingly, but they know that it is needed for computer science. What about history, political science? They hate that because they believe that it's absolutely useless thing. Just like some writers in New York Times say that, why do we need to study how to solve quadratic equations? Long division, right. I was tortured with that in school. I barely learned that. And now my kids are burned. Let's have a law prohibiting torturing the kids. So what can I say?
And also Feynman, famous Feynman, he said, I have daughter and son. When I come to my daughter, she says, please read me this book, this tale, fairy tale. And that's it. She goes to sleep. And I go to my son and start reading book. And he says, no, Dad, tell me, invent your own story. Tell me story about dragons. And I create my own story. So maybe there are different learning styles also with different people.
It's like we had a teacher of mathematics in the school in high school where I went. And most of us loved him. But when we had an anniversary, he died. One of the students, it turns out she just hated the way he taught. So different learning styles are good for different people.
Right, but society, like you said, focuses in on the sciences and the maths to quantify intelligence rather than literature or art. And my brain just doesn't work that way. And so what I get from your, and you'll read it in the survey also, while in your brain there may be a confluence, I see it as just 2 ways to educate our brains how to think. Either in a mathematical way, which is very linear, and a non-mathematical way, which is the only way I can learn. So that's my reply to you, Vladek.
Well, I wouldn't say, Larry would agree with me. I don't think mathematical way is very linear. Mathematics is very complicated.
Yeah, and there, there's some physics and stuff that's nonlinear, but that's where I'm stuck. I'm stuck at algebra and geometry.
Okay.
That's as far as I got. So, Larry, you were going to say something?
Yeah, I was just going to say, I think there's like a big picture thing to say here, and that is that, yes, like Howard Gardner has multiple intelligences theories where there's like 8 dimensions of intelligence, where the mathematical kind of reasoning is just one of 8 dimensions. And so there are many ways of being intelligent. We wouldn't want to reduce intelligence just to mathematical ability, just as we wouldn't want to reduce religion to just the ritual one does. So the journey of this is for me is really learning how to see the fullness, the full spectrum, and the full beauty. And even with like denominations within Judaism, I know most people on this particular call would probably identify as Reform Jews, but I've heard some broad brush statements today, both about Orthodox Jews as well as Orthodox conceptions of Reform Jews, and I disagree with both of them. I think both can be caricatures, and both can be stereotypes. I grew up, on the Reform side of conservative, but I married into a modern Orthodox family, and so I really see both sides. And I wouldn't be who I am without growing and learning from both sides of Judaism. So for me to reduce it to either box doesn't work. But maybe that's just me. I don't know. So, are there any other, has anyone else had a chance to come up with we have time for one more question if someone just has a burning question they feel needs to be asked. If not, let's all give our speakers a hand.
Well, thank you very much. Thank you.
Very provocative and wonderful things to think about. And again, this will be recorded. So if there's a piece of it you missed, or if you want to follow up with some of the references our speakers gave us, you'll be able to look that up on the Temple Mount Sinai YouTube page. Rabbi Zeidman has reposted the survey link. So if you haven't had a chance to take the 2-minute survey, please do that, especially with a crowd this size. Every person's comments count. So we really want to get everyone's comments in there. And we look forward to seeing people at our next talk, which again will be October 17th. So notice that it's a Sunday, not a Thursday, like most of our talks have been. And it's at 1 p.m. rather than the usual 6:30. And that's because she's in the UK. And if we did it at 6:30 our time, I don't know what time that'll be for her, but it'd be middle of the night probably. So we want to be kind to her. So be sure to be on the lookout and register if you haven't already registered. Rabbi Zeidman, do you have any closing thoughts?
No, I would simply say, as Vladek referenced and Olga referenced, these are the words of the living God. And in that case, right, all learning and all opportunities for understanding this world are sacred opportunities. And so I would simply offer the blessing, kind of after the fact. Baruch atah Adonai Eloheinu melech haolam asher kitshanu b'mitzvotav v'tzivanu la'asok b'divrei Torah. We give thanks to you, O God, ruler and creator of the universe, who has allowed us this opportunity for sacred learning and for deeper understanding of our own selves and for this world. And I'm grateful to all of you for joining us. And I hope that this is a conversation that continues in your lives for many, many years to come as well. Thank you, everybody.
Thank you very much.
Thank you.
Thank you.
Take care.